Hello everyone. So let me check the stream is working. Okay. So here we are with another live coding session. Today we are going to program a classical algorithmical game called Theseus and the Minotaur. And the aim of the game is to escape the labyrinth as Theseus, a figure from the mythology. But there's a catch. Our opponent, Minotaur, moves 2 moves at a time, while we move only 1 at a time. So he has an advantage, but our advantage is our wit and cleverness. So that we can choose to trick the Minotaur and escape like this. So let me show you an example game. So here if I move, by the way I'm the yellow dot and Minotaur is the red dot, and our goal is the exit right here. So if I move right and down, I will be dead because Minotaur moves twice. So what I need to do here is to go left and now go right, and now Minotaur is capsuled inside those walls, and now it cannot easily move. So now I can easily escape. By the way, each turn Minotaur checks the distance, and if it can find a way to reduce the distance between himself and the player, he will move in this direction. And now, as you see, I managed to escape, and now I can go into the next level, I believe. For that I will restart and go to next level. So here it's a little bit more complicated because it's not that easy to trap it, but what I can do is to go right as much as I can, and then maybe I made a mistake. Let's see if I can trick. No, I couldn't trick it. Let's try that again. So I guess the trick was to go up, and like this, maybe I can trap it. Okay, here as you see it could go 2 tiles bottom, but Minotaur chose to go horizontally because in his algorithm, if he can close the distance horizontally, he moves horizontally first. So he prioritizes horizontal movement. So this is why I was able to trick him and escape. And I don't know, I mean I couldn't figure out a way to beat the fourth level, but here we are in the 3rd level, and let me restart that really quickly and go to 3rd level. So here, okay, let's restart again. We have a lot of levels. So here I have the option to wait here 1 turn. I do this by clicking W, And now, since the Minotaur is trapped, I can move like this and escape quite easily. He will not catch me. Alright, so we have to code a couple of things. First, we need to create the maze. Then we will code our movements, in my opinion, and then lastly we will code the enemy movement. So let's start. Okay, so to code, before all that, of course, we need to create a project and use version control. So for that, I will go to GitLab, create a new project. This can be public, since this is for educational purposes, and I will not. Okay, we can also initialize it with readme, I guess. Let's create project. And I will be cloning this with SSH algorithm. Let's open a command prompt and go to my projects folder, and here I will be cloning the project. Let's wait a couple of seconds, and here it should be around here. Okay, this is the project, and I generally use a smart git as my git client, so let's set it up as well. It needs a little update, so alright, let's not open any existing project, but to add a new one, and this will be here. Okay, it's located nicely here, and now we need to add a git ignore. Also, currently this is not openable in Unity yet, because this is just an empty capsule, empty project. So to open this in Unity, we need to go inside the project folder and create two folders. One of them will be assets, and the other one will be library. So now this should be openable in the Unity, and it did not see the change for some reason here. But we will check this later. Okay, so we have empty folders. What I'm going to do is also add a git ignore file. I have a git ignore file created already from my recent project. So this is why I'm going to copy this one, copy file contents, and then I will be pasting it inside this text editor. By the way, this is generated by gitignore.io website, but gitignore.io doesn't generate a perfect gitignore, unfortunately, so I made some changes along the way because things change, rider changes, and also Unity changes, and new generated files appear, so you need to ignore new files. So this is why I'm using a gitignore file that I trust. Alright, so we need to change the file name to .gitignore, so the extension changes, and now Git recognizes this file. Alright, and what we can do is to actually make our first commit. Let's name this chore gitignore edit, gitignore file edit, and I use semantic commit messages, so I start with chore when there's something I have to do. I also use feed when there's a new feature, and I use fix when I fix something with my commit. So let's commit this one and see if we can push this as well. Now it says push succeeded. If we refresh this one, we should be seeing gitignore. So everything works fine. And let's go back here. So what I'm going to do now is to open up my project. I will add project from the disk, and I will choose this one, and I will open it with the most recent Unity version. It should be that one, I believe. It's long-term support, but it's stable enough. Okay, so now Unity is going to generate a lot of things. While it's doing that, I'm going to refresh my memory about grids in Unity. I used this grid system some time ago, so
In this video, we're going to make a grid map to cut our world into various sections. This can then be used for making all kinds of systems like a heat map, pathfinding, or define valid building areas. Hello and welcome, I'm your Code Monkey, and this channel is all about helping you learn how to make your own games with in-depth tutorials made by a pro, and which is not free. Let's make monkey up, and then you are.
I tried to see if this one has walls.
Underneath. So you can see how this class, this code is, if you'd like to know.
Okay, I guess I had to stop
Hi, this is Unity Lessons.
it manually. Okay, so let's go back to normal grids tutorial.
To cut our world into various sections. This can then be used for making all kinds of systems like a heat map, pathfinding, or define valid building areas. Split into various squares. Each square is a brick heat map. Alternatively, you could use it using the tile map for the ground tiles, as well as let's also store these as variables. Now let's also create our underlying input. And on start, let's create a new grid with second dimension. So this is how you cycle through a multi-dimensional record. Alright, so now it's in here that we want to display a certain element. Okay, so here, just to make sure that our cycle is working correctly, let's do a debug.log on the X. And then
Oh, I thought Unity has a native solution, but apparently it's not.
Do a debug.drawLine. So here we need a start.
Alright, then I will have to code my own, no problems. I thought maybe I could use, you know, tile maps or something like that. Actually, let me search for tile maps in Unity, because this could really save me up some time if this works.
Hello.
Hello everybody, Chris here, and in this video I want to show you guys
I mean, normally for this type of a project, tile maps would be better if they are used. But I might also use simple grid system as well. So this is what I'm thinking. Yeah, I guess I will start with simple grids first and then move to tile maps, maybe later. Okay, so let's go to 2D version. Now I'm going to open a folder called scripts. Actually, before that, maybe what I should do is to close Unity and then commit the generated files. Right, so now I'm going to open the game again. Maybe we can delete this and create a grid generator. I don't know. We will also have a folder called scenes, and here I will create a new scene and name this one first level, and I will jump into this scene and work on it. So here I will create an empty game object and call this grid generator, and let's reset those to 0, 0, 0 and add grid generator scripts inside it. And I will open this with Rider. Alright. So at awake, what we are going to do is to create a grid, and for that I will need 2 for loops inside each other. So this will be starting with, okay, let's call this x and the upper limit of that will be, I don't know, 30 or something. And inside it we will have another for loop, and we will call the iterator y, and the upper limit will be 30 as well. So after that, of course, we need to have a starting point. Let's have a starting point that is dynamic. So this will be vector 2, and the name of the starting points will be starting point, and this will be a property point. So this will be a property, and that means we will have a get and set methods implemented within, and it doesn't have this semicolon in the end. And since, like, if we write it like this, it can be serialized in the editor, but it's also it can also work as a property, and it can also have get and set methods working. So here inside those two for loops, I will generate a tile, square basically. So let me think for a second. Okay, we will also have a float value. So let's have a float value, and the name of the float value will be the break between tiles, and let's name this B. And here we will instantiate a tile, and a tile will be a game object. It's going to be a prefab probably. So let's have a game object called tile. And actually it's not going to be a property, so what we can do is to do that. So this is going to be a tile prefab. And what we are going to do is to instantiate this tile prefab multiple times. So let's check. Tile prefab, and as starting points actually I need to transform this a little bit. So let's have a vector 2 called spawn points, and this will be starting points plus x times tile size plus y times tile size. So let's do it like this, new vector 2. And we will have a grid's parent object. Let's define this tile size as well. It's going to be a float. Like this. Okay, so we spawn a tile from this tile prefab, and then we set the position of it in this line. And what we can do is to take this somewhere above, like this. and that way it's only gets initiated once, so instantiated once, I mean. Okay, so this should spawn grids for us. Let's get rid of those lines. And let's see what is going on in Unity. Okay, let's set the tile size later. Starting points can be minus 15, minus 15. And let's keep, I mean, break between tiles could be 0.3, but this will not affect it for now. And now I will have to have a tile prefab, you know. Let's have a grid parent. Object. This will be an empty object as well, and we will put this inside prefabs folder, and also we will assign it in the editor. And inside prefabs folder, excuse me, so inside prefabs, inside our level, we will also create a 2D objects or 3D objects, it doesn't really matter. Okay, this is going to be a nice tile for us, and I will reset it, and I will make this a prefab as well. Actually, let's delete it, and let's start from scratch. I will name this tile, and now make it a prefab like this. Right, and inside grid generator, I will set this. Actually, I have to delete this again, and here I will set the prefab inside the editor. So let's start, let's save our scene and let's start and see what happens. Okay, so we have a couple of tiles, which is quite nice, but for some reason I cannot see them. Okay, let's separate our game. It's scene. Okay, inside scene, I want to see the location of the tile, and everyone is spawned at the same location, as you see. So we need to fix that. Also, there's an error. Maybe we can focus on this later. Okay, because the tile size is 0, I believe, right? So tile size should be the size of this object, size of this tile. So it should be 1 as default. Let's try 1. and see what happens. Okay, now we have a bigger tile, and if we disable one, okay, they are nicely separated. So if, for instance, we can disable this one, yeah, the location of everything looks normal. However, they are really together. We need to separate those. So let's do that now. So I'm going to save this, and I'm going to have a break of 0.1. Let's go here, and now we are going to add a break. Alright. Okay, so this should work fine in my opinion. Let's try it. Okay, everything looks great. So we can put some walls, etc. Yeah, it looks really nice. It looks really nice. So the next thing will be a moving player. Before that, we need to save this, close the game, and make a commit. Now, since this is a feature, I will type feet and grid of the first level is automatically generated, and I will commit this one. And I can also push those. And let's go back. Okay, so now what we're going to do is to have a player and inside the player we will have a UI image for it. And the name of this guy will be Theseus image. And maybe we can download some images real quickly. Okay, let's download this one. And we will also need a Minotaur image. And it will be this one. This cute Minotaur will be our image. Oh, this one is actually even better. I want to have a PNG though. Let's go with that. This did not work. Alright. And here I will assign this sprite. Actually, let me change the names quickly. Let's make those sprites, by the way. And click apply, and now we can use them as sprites. Everything looks perfect. We can actually have a smaller canvas, by the way, but let's not worry about this right now. We can polish it later if we have time. Alright, so we can make this into a prefab as well, right? And let's delete this one and save this. And now we will have to spawn the player inside the grid. For that, I'm thinking a player spawner, just like grid generator. But this should also be responsible for location of the Minotaur, in my opinion. Right. So the great idea is to have a scriptable object or some kind of data form, data structure, which includes the spawn locations of Minotaur and Theseus and also the walls. Alright? So at some point we would have that kind of a data structure. So our maze generator should instantiate those objects in their own location. So maybe we can put those inside grid generator as well. Alright, so we can also make this another script, but for now let's put it inside here, because I don't believe today this will be a long enough class to worry about. So we have tile prefab, grid parents, alright. And now we will have a starting point of the player. So it's going to be something like this. Player spawn points. And we will have enemy spawn points. Alright. And I will create a region to separate things from the get-go. Let's call this grids. Tiles, and those will be about grid tiles, and another region should be player spawn and everything is much more tidy right now, and we will have another of those regions, and let's call this enemy spawn, and everything looks tidy. Also, let's make this into another method. Let's call this one instantiate tiles. Okay. Great. And now we will have another method called instantiate Theseus, and we don't have a method like this right now, so we will have one here, And also we will have another one called instantiate Minotaur. Okay. For now this will have to wait. We will be worrying about this. And here for the spawn points, I believe we will have an X value and a Y value. Uh, Okay, we will have something like this. I mean, I don't think I will have a parent for the players, so maybe let's not put this. Yeah, this should work fine, though I should change the name of this. So this should be player spawn coordinates, alright? So if this was an actual commercial game, a designer could just enter the coordinates and not worry about the actual floating numbers of the sizes of the tiles, alright? So similarly, this should be refactored to enemy spawn coordinates. Okay, let's go to here. And let's start this in 10 to 10, maybe 10 to 15. Let's put player prefab. And this should spawn. One thing we need to consider is to spawn in the Z direction. Okay, so for now it looks great, but it's there are two problems. First problem is to have this Theseus smaller, 4 times more, and the second problem is to make this above the grid at all times. So let's go inside player and make this half the size, and also the maybe the Z racing will not be an issue, so let's see if it does become an issue. Okay, it looks like we have 2. Okay, so what to do now? Let's move Theseus a little to the left and a little to the down, maybe. I actually want to see the real position of this guy. So that's the pivots of the Theseus. Okay, now I believe I will calculate the position one more time. Let me do this. Let's before that I will have a quick toilet break. Sorry about that.
Ay, sarap naman kakasya. Oo, tama siya.
Okay, sorry about that. I'm back, and now I will change the spawn point of Theseus. Alright, so if we reduce alpha points, it should be good in my opinion. Actually, the half the size is better. So yeah, like this. Okay. Let's go back. So the problem we have is about the interaction of UI objects and the regular game objects. So I'm thinking about turning this into a regular game object. So let's delete this and have a (3D) quads. And let's see if we can assign a sprite here. Okay, we got it, in my opinion. Yeah, this should be alright. Okay, now let's see where the player is. Okay, it's quite far away actually from the grid. Okay, everything looks nice in my opinion. And I believe even the subtraction will not be needed. So yeah, those I believe will not be needed. Great. And the spawn point of this guy is, the spawn coordinate is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, because we started with 0, the 10th location is here. And similarly, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So the spawn location is quite right, actually. So I will make a new commit at this point. Let's go to SmartKit. And Theseus is found at the right location. And let's push this. So now the next step is to spawn the Minotaur. Or actually even before that, yeah, actually let's spawn the Minotaur and then we can move on from there. So let's open this up, create a methods. Let's take this below the two other methods, and this is going to be so similar to instantiate Theseus. GMO stands for game object, by the way. Alright, so let's have something like that. In retrospect, these two could be only one method. So there could be one method responsible for instantiating two units, and also two prefabs could. Prefab of the Theseus and prefab of the Minotaur could be prefab variants of a single prefab called unit prefab, for instance. Those are options, but I am hesitant to do those type of refactoring at the beginning, because I cannot always we cannot always see the feature, and we cannot always say that this is a better better choice for maintenance, easy maintenance. So I go with the easier to understand approach, and once the change requests are made, then I change the architecture according to the new requirements. Alright, so even this looks quite clean in my opinion. No long methods. So let's go back to the Unity editor, and then we will need to create our Minotaur. Okay, so what I'm going to do is to take this, change the name to enemy, and change the image. And lastly, I will drag this inside prefabs. And I like to create an original prefab because their behavior will be a little bit different. Enemy will behave according to AI scripts. So let's delete this one. And now we can spawn the enemy as well. So enemy should spawn at 10 to 16, or maybe 10 to 16 should be fine. And we will have an enemy prefab. Okay, they are spawned adjacent to each other. The image should be smaller than that. Let's do that. Now let's spawn again. Okay, great. And now there's a condition we should check actually, and the spawn locations of the levels should be different, and if it's not different, then we should raise an error. So here I will have a method. Actually, at the beginning, I will have a method called check validates level configuration, and inside here I will check if layer spawn coordinates Okay, let's check it. And also, if the player coordinates are more than the number of grids, this should also raise an error. So what I'm going to do is to create a constant for that one, and this should be named grids tile number x and this will be 30. Similarly, I will have a grid number y and this will be 30 as well. We could put them in another script called constants, but for this size of a project I don't think it's necessary. Okay, and now we can check something like this. Those are looking good. Now let's check if everything is working smoothly. Here let's change. Yeah, they spawn at the same time and we got an error. This did not stop us from executing our code, but it's raised an error, so we will be clever to fix this type of a problem. Similarly, let's see what happens if we make one of those 31. Player cannot start outside the grid. Okay, let's check what happens if we do it like this. No errors, but we should have an error. So this is because of the fact that we start counting from 0. So what we need to do is to have an equals here and here. And now we should get an error. And if we make this 30, we should get an error. We should get 2 errors. And we got 2 errors because both Theseus and Minotaur tries to start from outside the grid. Okay. So I believe this deserves a commit. So I will make one, and I will make those fixed again and save. Close Unity so it generates needed files, and now we will have okay. Now we need to move the player, right? So let's open Unity again. And in player, I will add a player movement script. Just like this. And here I should also put this inside scripts folder. Alright. And here I will check for the inputs. So we will use up arrow. Also we will need to have a turn system. So it should keep whose turn it is. And and it can be a static class in my opinion, and it's going to be turn manager. And here I will keep the turn of the player. So if it's not player's turn, we simply return. If it is player's turn, then we are here. So this is a guard clause. And we will move the player. And we will have we will need an enum, I believe. Let's generate the code. And this enum will keep 4 directions. Actually, maybe it's better if this is a struct. And I will have 4 directions. Oh, actually Unity has those, yeah. So I actually don't need directions, I believe. I forgot about those, yeah, it's better to use those. Okay, so let's delete directions. And now let's move the player, okay? So to move the player, we are going to smoothly transition the location of the player in this direction. But also we need to get the data from grid generator, right? And also we need to, at the end of this, we need to change this value to false. So let's not forget about this. And now we should get location of the player. So for that we will use transform.position. Actually, maybe we can use transform.gameObjects. I'm thinking how to move the player. So since it's not required to have a rigid body, we should not do physics-based movements. So transform class transform.move should be good, I believe. Before that, let's calculate the last position, shall we? So for that we will need grid generator. Give me a second please for the toilet break. Sorry about that, now I'm back. Okay. Can we make this less static? Let me check it. Okay. Yeah, it doesn't really work right. We have to do a lot of refactorings. So let's not do that. I like using static classes and I don't like mono behaviors that much. But for time problems, we'll keep it like this. And unfortunately we will have to reference this grid generator inside player moment scripts, which is something that I don't quite like. But for now it shouldn't be that problematic. And we will make this read-only since this will not change later. And at the start we can get it dynamically. Even in awake, we can get it dynamically. So I actually don't like using find methods because they are not performance. But for a 2D game it shouldn't cause that many problems. And also if we were to decide not use this later, what we could do is to make this into a singleton type of thing, and then get the stuff from there. Also, we can also get level configuration from a scriptable object directly, maybe. So those are good. Those are better alternatives. For now, let's keep it like this. And here, what I'm going to do is to use this reference to reach the tile size. So we will have something which I will call push vector, and this will be the direction times tile size plus break between tiles. And I will add this to the player's position. Okay, it doesn't like that. Oh, actually it likes that, but what we need to do is to cast this to a vector 3. Okay. Now this should snap the objects. Once I hit up arrow. Okay, it's moved one tile. So let's try this again. So as you see, when I hit up arrow, it moved one tile, then it stops because it's not my turn anymore. It's great. Let's code the other movements, shall we? Of course, we will use else. So the player cannot simultaneously press two keys at the same time. And get key down arrow. left arrow. And right arrow. Great. Let's separate those, and I like one-liners for guard clauses, so let's keep it tidy like this. Up, down, left and right, everything looks great. And let's go here. Okay, upwards, downwards, rightwards, and leftwards. So, this deserves a commit, in my opinion. Let's commit it. Okay. I'm thinking what to do next. So we can play one turn right now, but we cannot move 2 turns. So what I'm going to add now is enemy movement speed. Alright. Great. And here, inside turn manager, actually I'm going to make this private and have a getter, have a setter. Change turn. This will be methods. And here so we encapsulated this one. And now we will use this one inside player movements.
sorry. Now here we will change turn. So turn manager dot change turn. And here what we will have is to have an action. Not achievements, but action. And this will have a boolean inside, and the name will be on turn changed. And this will be static. And inside I will include whose turn it is. True means it is player's turn. And now inside enemy movements I will subtract to this event, and when it is enemy's turn I will move the enemy in a random direction for now. This should be a mono behavior, and we are going to add this inside enemy. And inside a wait function we are going to subscribe. Actually let's do it. Yeah, inside awake let's subscribe to turn manager dot change turn. Sorry, on change turn, on turn changed, and we will subscribe, and we will handle on turn changed. And we need to unsubscribe to this method. So here I will write it like this and unsubscribe. And here we will have a similar method to this one. Let's call this move enemy. So we will have a guard clause like this, and if it's not player's turn, then we will move our enemy in a random direction. For now, let's always move it right. Okay. And inside awake, we need to find grid generator, just like we did in the player moments. Okay. So this should hopefully give the turn back to us. Let's check what is going on. While it's opening, I will get some water. and we'll be back in a minute. Alright, I'm back again, and I drink some water. I should have grabbed one additional bottle, but whatever. So yeah, I'm back, and now we should move the enemy in a certain direction, right? Let's try. I should have added the scripts to the enemy. So let's go to enemy. Actually, enemy should have an enemy movement, just like this, and it will get grid generator once the game starts. And when I play, enemy will automatically play to the right. Exactly. Nice. There's a possibility that I can send the Minotaur towards the grids, into the space, but we will fix this. For now, let's commit this. So now what we need to do is to add walls, and there are a couple of different ways to add walls, and I'm thinking normally in a corporate setting walls should be included in the level configuration, so we would read it from a scriptable object or maybe a JSON. Maybe we could even get it from the server. So maybe inside grid generator we will generate walls. And every wall should have a starting position and a length, right? And it also needs to have a direction, so it either goes to right or goes to bottom. Okay, so let's define a wall first in a separate class. So it's going to have a vector 2, and we will call this starting coordinates, and we will make this a property like this. And then it will also have a boolean direction, and this will actually be an enum, and let's create an enum for that. Wall direction, and this enum will have horizontal and vertical directions. And do we need to add any additional thing? I don't think so. So this should be enough. So let's go back to grid generator, and we will need to have another region called wall spawn. And now this will read from a line, from a list, inside this list we will have walls, and here I will call this walls, and we will also have a wall prefab. Alright, and here we will have instantiate walls. And I will move this method below. And the idea will be to go through each wall in a for each loop and then generate a small wall prefab multiple times. Okay, so how do we do that? I will do something similar to that, in my opinion. So, for each wall, in walls, I will do something like this. I will also, yeah, a wall should have a length, right? So tile length, and this will be an integer. So yeah, this looks nice. While lengths is bigger than 0, I will instantiate a small tile. Alright, so I will cache it. I should make this public, and I should make this private for now. Okay, and for the first tile, I need to instantiate it right at the position, right at the coordinates, right? this will have a wall parent, by the way. And this will have a wall prefab. Alright, I will delete this in a short moment. Let's make starting points, starting coordinates public. So starting point is the origin point, right? And we will spawn our stuff there. And right after, we will have something like this. And this will be wall GMO. And let's see how this works. I have doubts if this will work or not, but we'll see. Let's open Unity now. We will create a wall prefab. And we will have a list of walls. Let's create a wall parent first. Reset this and move this right here. And now yeah, this looks good. Actually, I can make this in a prefab because it's better for merge conflicts later on. And let's create a wall for it. I change my names. Yeah, I needed something with just like this. Great. Actually, this is even better, it's squared. And let's name this gray wall. And save it in desktop. I don't know if Unity will accept this. Let's search for gray wall. Actually, let's convert this really quickly. Great. And I will choose my gray wall. Actually, I will simply drag it. And I will convert it to PNG. Let's download this one. Search it here, okay. We will turn it into a sprite. Apply. And we will do something like this, where we have a quads, and inside quads we will have an image. So let's name this quads, and let's add an image, actually not like this. So it's going to be something like this. But this needs to be seamless. So those white backgrounds should not appear. So for that I will use something called remove backgrounds. And I will remove the background of this. So what I'm going to do is to delete this, actually, and I will delete this as well. And we're going to use this one. And now if I edit here, as you see, it's going to be perfect. I just have to change the scale to 0.1, maybe 0.05, and this will be twice as large. Okay, this is great. Actually, let's reverse those. Okay, so we will shorten this for sure. Let's make it twice. Okay, this should be good. And let's go back, make this into a prefab. It's already a prefab, so we can actually delete this, and inside brick generator we can assign wall prefab, and now we only need to have a list of walls which we don't see in the editor. So let's change this. Or do we see them? Let me check it. We don't see the walls in the editor. So let's make this public. And now we should see it in the editor. That's interesting. Let me check. Oh, for some reason Unity doesn't serialize lists. Because this is not a field, right? So yeah. There's a way to serialize lists as well. But before that I will take a break, and after the toilet break I will be back. Hello again. So, yeah, I was going to list walls. Um, Normally we would use something like Odin Inspector for that. Let me Google as an alternative solution for it. We can close those images and oh yeah, normal serializable could work. Oh, so the wall should be serializable. Let me do that. And let's see what is happening if we use this. With Odin Inspector this is quite easy. Okay, so I need to put those in a walls table. So I need to create a field first, right? And above it should be serializable. And inside it should have a list of walls, which is serializable. And here I will change the type to walls list. And if I serialize fields now, Alright, so let's make this a field now, and this should work, in my opinion. Let me check. Oh, okay. There was an error.
Saat 2 çeyrek geçiyor. Yemek yer misin?
Here.
Nerede? Kutusu.
Let's make this public. This should work fine. And now we have a list that is serialized, but the items are not serialized. That's interesting. Okay, now it suggests scriptable objects. Yeah, I was thinking of doing that anyway, so this could be a good moment to do so. Right. What I'm going to do is to take back some things. For instance, I will delete this. I don't think this will be needed. We are going to use scriptable objects. Alright, so now we need to create a scriptable object. Just like this. Let's go here. And the name of that will be wall list, in my opinion. Walls list. And yeah, this is going to be a scriptable object. And I will remove those. And yeah, everything looks fine. Oh, actually, maybe it's better to use. I'm thinking of either making individual walls a scriptable object, or maybe a list of walls in a scriptable object. So yeah, let's. I have to test it out first. So here, if I create a custom wall list, what is going to be? What I can do is maybe turn this into a wall. And since wall is serializable, this should be working fine. But yeah. It actually doesn't. Okay, now it's working fine. So we will make this 5, and we will fill each element separately. But now still wall is not serializable for some reason, even though it says so. Now this is interesting. Yeah, I see. We cannot do it like this, unfortunately. So I will delete this altogether and go to the suggested route, which is using this like this. And we will create wall separately, and after creating each wall we would have to create like drag them into the list. Okay, so now I'm going to create a custom wall. shouldn't be looking like this. Should be custom wall. Yeah, I will need this one. And it should inherit from scriptable objects. And I'm going to delete this. Actually. And in the grid generator I will have a list of walls. Okay, this looks nice. Now I will create a custom wall. I will have serializable fields. Great, so this is what I wanted from the get-go. And now what I can do is to create a folder, and I will create a folder called walls, and I will put this here. And the name of this will be level 1. Actually, let's name this 1 level 1 wall 0. Okay, let's count from scratch. And starting coordinates can be 0, 0. Let's keep it horizontal. And tile length will be 3. Alright. And now we will create another one. It's going to be let's get it from here. So level 1 wall 1, alright. And this is going to be a vertical one, and this is going to start from 0, 0, and tile lengths will be 30. Okay, and I want to copy this twice, rename this into 2, and rename this to 3. So we have 0, 1, 2, and third wall. And this is going to start in 30 to 30 position, and also this is going to start from 30 to 30 position. One of them will be horizontal. Let's make this horizontal and see what is going on if we configure it like this. Let's go into grid generator, and here I will try to drag my walls. Okay. Actually, you know what? I will create some folders. So level 1 will keep those. We'll keep all of those stuff, and I will have 2 folders for other walls. And now, since they're all inside level 1, I can get rid of the additional words. This is more tidy in my opinion. Okay, so, and we reference all of them quite nicely. Now what we need to do is to test the logic of spawning walls. Interesting. Let's go inside wall parents. It actually generated something. However, everything is at the same place. This is not what we wanted, right? Okay. So how are we going to fix this? By the way, let me check. So the position should be a little to the bottom, a little bit to the left, firstly. So for that we are going to add tile size, maybe we are going to subtract tile size halved. And starting coordinate x. We should be using this number. Main tile length. So let's count up to the tile length, shall we? So this is going to be starting at 0, and while the build tile number is less than remaining tile length, I will increase build tile number one by one. And now for each tile this is going to be a little bit to the right, a little bit to the above, maybe. Yeah. Okay, I got it. The wall has a direction, right? Let's make this public. If wall dot direction equals horizontal, then we are going to calculate spawn points. Else, again we are going to calculate spawn points, but it's going to be a little different. Okay. Now this is great. Let's test this out. Sweet. It's just where I wanted, right? Nah, I need to do a couple of things, but the idea is kind of right. I need to move them a little bit to the right, to be honest. Yeah. Okay. Actually, you know what? Let's test this again. I want to see something. So this is quite nice. I just need to move them to the right. So again, maybe I don't need those. I always think I need those, but then I change my minds. Now it's better. Oh, I need to take them a little bit to the bottom, right? So if we are spawning horizontally, then I will reduce the y value.
Was it?
And if we are going to spawn vertically, then I will actually spawn a different prefab, or maybe rotate my prefab. So let's see. Let's test this for a second. Okay, so horizontal walls look pretty okay, and even those look okay. And vertical lines, vertical walls should be in a different place. And their x value should be different. Okay, so let me do that. So we will use this for the x value of the vertical walls, and also we will change the rotation 90 degrees. And this will be turning in the z direction, I guess. Those are defaults. Actually, I will check it really quickly. Rotate 90 degrees unity. So I will save some time. Okay, this one solves the issue, I guess. If that's the case, then great. Let's delete this and test this. Alright, and vertical ones are for some reason I cannot see the vertical ones. Okay, I moved it in the wrong direction, it looks like. So which direction should I rotate? Not X, but Z, I believe. Yeah. So this should be like this. it is going to rotate around z-axis 90 degrees counterclockwise. Sweet. So it is all looking fine. You will notice there's a problem, but it's not actually a problem. Those walls go outside the grid, but this is because of the customization here. So if I change the scripted objects, it's going to work just fine. Let me do that. So it's going to be starting from 0 30, and this is going to be starting from 30-0, and I believe these should work fine. Yeah, exactly so. And we have an opening here, but we can quickly change this by changing the length to 30. Sweet. So we've got a nice grid. Okay, we can commit it like this, and here I can move, and still enemy moves fine. Alright, let's close Unity, and I will commit this.
Ama saat 3'e çeyrek var. Bugün de sana ısıttım, yedireceğim, dışarıda yemek yiyeceğim. Konuşuyor. Evet.
And I will commit this, then I should go and eat something, because my father cooked some meal, I believe. And I will come back in, I believe, 10 minutes or so. See you later. Hello again. So I'm back from the meal and now we are going to continue to our game. So the next thing we are going to do is to add a mechanic, add a rule to our game so that the player will not be able to cross the wall. Okay, so for that we are going to actually let me for that we're going to go to our player movement script and add a condition inside move player. So this condition will be if is wall blocking direction, and this will take direction inside, and it will also take the position of the player, but this will be enough for now. So, and if this is the case, this function will do nothing. And this is wall blocking direction will be a utility function. And this function will be used by enemy movement script as well. So I'm going to create a new script and rename this movement utility, and I'm going to create a class, and I'm going to take this code inside here, and here it's going to call movement utility that is wall blocking direction. So this is going to be a static class, by the way, and this script will also be static. And this will be a public method. Great. So, what this does. This will take transform dot position inside, and so we have vector 3. And this will be start position of the movements. Okay. And this is going to return something. It's going to return true. Sorry, it's going to return false. Now let's see if the wall is blocking direction. Here, I'm going to use a for each clause, and I will need to use the wall list inside grid generator. So, since I will be referencing grid generator, I will find it here. Let me check if the Steam is working fine. Okay, so here I will have grid generator, and I will fill it, and this should be static as well, of course. And here, if grid generator is null, then actually it suggests me if this one is null, what I'm going to do is to find it just like I did here. Alright. And let's make this public, because I will be reaching it. And let's be type safe, and if the wall, okay, if the direction of the movement is vertical, then we are going to check horizontal walls and vice versa. So and this is going to act like a guard clause. If the wall is horizontal, then we need to see the movement start position, right? So we will need the coordinates from the start position. We will need the coordinates of the player somehow. So actually, what I'm going to do is to keep it in a field. Okay, so this is going to be a vector 2, and this is going to be named player coordinates. Alright. And I will change the coordinates so here we will initialize it by using grid generator. So this is going to be public. Telefonun sesini kısar mısın? And according to the coordinates, according to the direction, I will change coordinates. Now I can get the player coordinates So it's going to be something like this.
Great.
So, this could work. Let's try this. So something is false. Something is null. This is not used, so we can remove this. And let's go into debug mode and see what is being null. Oh, so the player's movement is null. Alright, alright. Yeah, I should have initialized it right around here. Okay, this should work now. Yeah. Okay. Let's delete those lines. Let's close and open. Okay. It doesn't actually block for some reason. That's interesting. Let's go into debug mode again and see what is causing the issue. I made a calculation mistake, probably. Okay, I noticed something. It actually stops. Sweet. So it actually stops, but since I yeah, the placement of those lines are wrong. So let's get rid of those first. because there is no need to update coordinates if we cannot move. Um, Actually, one liner would be enough. So this should be enough. So I don't think I will need additional stuff. So I will just change player coordinates and this should work, I believe. Let's try it. Great. So I'm pressing the up arrow, but it's not going up. Interestingly, it's not going down either. And left's limitation does not work as well. So, interesting stuff is going on. So I need to check the logic here to debug. I will take a little break first, and then hopefully I will be better suited for this task.
Okay, hello again. So, what do we do? Maybe we can, we can go into the debug mode and see what is the problem.
Okay, I'm on the edge. I enable breakpoints and I press left. Everything works fine except once I touch the wall, I cannot leave the wall. So I guess I know the reason for that. So according to the movement direction, we need to check something else. So let's make this up, down, left, and we will need right. I'm thinking of a more clever way of doing those calculations. So maybe if I how can we do it more cleverly? this might just work. Or down and up. Yeah, this should work. For some reason I cannot even move. Wait. And now I'm starting to understand. Okay. So if we're trying to go down, only the ones... Okay, actually I got a little tired, so maybe if we calculate it with drawing, then this would make sense. So let's consider that we have 4 walls, and this is our player. So if we are going to go up, the coordinates for this player will be 0, 0, and this coordinate will be it should be 0, 1. So what we are doing is to add the direction You know what? I actually wanted to check the coordinates of the walls. So let's make it 10. And now it's going to be a shorter wall. Okay, this is 10. So it starts at 0, 0, which is fine. And it goes 10 tiles, which is great. And it should stop me when I want to go down here. And it stops. But when I want to move up, it also stops me. This is weird. Player coordinates are 5 to 0. Okay, and y value, okay, they're great, they're equal. But this should be +1 if this needs to stop. So, in my opinion, this should work. this should work ideally, but we need to test this, of course. Yeah, if I just delete this part, it should work fine. Okay. Everything works just fine. And since there is no wall here, I can't walk. But here, if I try to move down, it's not going to happen. Alright, this is also solved. Let's fix everything to be 30 AM. And let's commit this. And I will just push this. And now we need the monster, we need the Minotaur to be blocked by the walls as well. Okay. So this one works nicely. This is a long function, to be honest. And I would like to shorten this before we move on. So this is a common control thing. So those lines repeat each other. As you see, this one repeats this one. And this is also common. So this could be changed, and this could be much more shorter. But for now, let's keep it like this and go into enemy movement. And here, inside move enemy, we will check if the wall is blocking, and This one gets the player movement scripts, but this doesn't have to be that way. So we will have an optional parameter called is player, and this will be true for defaults. But if it's not the player, we will change this line. So actually, I will need to do a little bit of refactoring. Actually, I want to change the name of this. And this one will have coordinates.